Good day. This is a course, a short course on battery technology, and I welcome you to partake in this short course, which will be conducted by online media. Today we're going to look at the workhorse of a lot of the electrical and electronic technology sector, which is the provision of energy in a small packaged form, which is transportable and possible to allow autonomous operation of electrical equipment away from the grid. And this is the good old battery. One of the first inventions within the electrical engineering field, which had a major impact on the development of the use of electricity in our age. So some of the things that I will cover in terms of the objectives of this course is to apply and gain, I would like the participants to apply and gain an in-depth knowledge on battery impedance techniques and result analysis, to identify the components of cells and batteries and classify them according to secondary, primary, and so forth in terms of being rechargeable batteries or non-rechargeable. We will look at the concept of reserve batteries, fuel cells, and charge and discharge cycles, as well as specific energy and energy density. Some of the core definitions within battery technology. Okay, so let's start from the basic concepts. A battery, what is it? A battery is a device that converts the chemical energy contained in its active materials directly into electric energy by means of an electrochemical oxidation process, oxidation reduction process, in fact. So we would call it a redox reaction. So essentially, batteries are redox reaction, have redox reaction within their major method of operation. So it's that particular chemical process. In the case of a rechargeable system, the battery is recharged by a reversal of the process. So the redox reaction gets then reversed. So if we look further, we will see that this kind of reaction involves the transfer of electrons, basically, from one material to another through an electric circuit. In a non-electrochemical redox reaction, such as, for instance, the good old rusting or burning, the transfer of electrons occur directly and only heat is involved. But as the battery electrochemically converts this chemical energy into electrical energy, it is not subject, as our combustion or heat engines, to the limitations of what we call the Carnot cycle, C-A-R-N-O-T, Carnot cycle, dictated by the second law of thermodynamics. So batteries, therefore, are capable of having higher energy conversion efficiencies than the combustion or heat engines. While the term battery is often used, the basic electrochemical unit that we need to talk about, that we start from before we end up with a battery, is, of course, the cell. A battery, by definition, consists of one or more of these cells connected in series or parallel, or both, depending on the desired output of the voltage or the capacity that we are trying to develop the battery for. The cell consists of three major components. The anode, or negative electrode, which is often called the reducing or fuel electrode. And this is the part that gives up electrons to the external circuit and is oxidized during this electrochemical reaction. The second part is the cathode or positive electrode, and the oxidizing electrode, as it is often known, which accepts electrons from the external circuit and is reduced during the electrochemical reaction. Now, in terms of cells and batteries, cells versus batteries, can we even compare such a thing? As we said, the cell is the basic electrochemical unit, providing a source of electrical energy by direct conversion of chemical energy to electrical energy. The cell consists of an assembly of electrodes, of separators, of electrolytes, and terminals, which is where we get all of the energy. A battery, therefore, consists of one or more electrochemical cells, electrically connected by means of conductors in an appropriate series or parallel arrangement to provide the required operating voltage and current levels, including, if any, monitors, controls, and other ancillary equipment. For instance, might have fuses, diodes, terminals, and markings included as part of the physical implementation of the technology. Although much less popular in some publications, for instance, the term battery is considered to contain two or more cells. Popular usage of the word battery, on the other hand, and not cell, seems to be a product that is sold quite widely. Popular usage often dictates how society sees things, and but not necessarily as it is accurately reflected within the domain of science. So the term cell is used, therefore, for describing a component of battery and its chemistry, and we can therefore say that the term battery can be used representing performance characteristics, etc., of a product, due to this confusion between what we would call popular use and correct scientific use. So sometimes there's an interchange you will see in the usage of the term, but essentially, as long as we remember that the battery can consist, at least in its minimum form, of one cell or more cells, and that the cell itself therefore represents the lowest one, the lowest form of compact energy from the electrochemical process, from which we can compose higher modules of this. So another part that is very important in terms of the development of a cell or battery is this, the electrolyte, or what we call the ionic conductor, which provides the medium for transfer or of charge as ions inside the cell between the anode and the cathode. The electrolyte is typically a liquid such as water or other solvents with dissolved salts, acids, or alkalis to impact what is called ionic conductivity. Some batteries use solid electrolytes, which are used as ionic conductors at the operating temperature of the cell. So there is a couple of developments that where we find that batteries use slightly different technologies in terms of providing that ionic link. The most advantageous combinations of anode and cathode materials are those that will be the lightest and give the highest cell voltage capacity. Such combinations may not always be practical, however, due to reactivity with other cell components, due to polarization, due to difficulty in handling and high cost, and other deficiencies, this needs to be considered, therefore. In a practical system, we will often find that the anode is selected with the following properties in mind. We look at efficiency. We look at high coulombic output, amp hours and then we also look at good conductivity, stability, ease of fabrication. What else? Low cost, of course. Hydrogen is attractive as an anode material, but obviously must be contained by some means which effectively reduces its electrochemical equivalence. So it can become difficult to use what we would say is maybe an effective element as anode. Practically, metals are mostly used as anodes, an anodic material. Zinc has been predominant, and of course, this is how we will look at the technologies from here onwards, where we're going to consider the use of zinc and of course other materials like lithium and so on. So I'll end it here today for the first part of our introduction of this battery development course, and we'll continue with part 2 in the next lesson. Thank you.